Okay, hello everyone. My name is Meta Tamel. I'm a software engineer and developer advocate at Google, based in London. So thanks for having me here today. I've been to Cardiff a long time ago, like more than 10 years ago, so it's great to visit again. Today I want to talk to you about open standards for building event-driven applications in the cloud. If you want the slides, it's at this link, and I'm going to share the link at the end of the presentation as well. And I've been doing software engineering since 2005, I guess. And in one of my first jobs, we were building an event-driven framework. I don't know if anyone used Flex data services back in the day. It was Adobe's way of connecting Flex applications to the backend. And I remember building, the consumers, producers, channels, all the event-driven stuff that you can think of. Then after that, I worked at Skype. We were building our own messaging framework there. Then after that, I was at Microsoft. We started using Azure, and we had the Azure queues and topics and things like that. And now at Google, we have Google Cloud Pops Up, and then we have this new thing called EventArc. They're all event-driven. They're all trying to do the same thing, where you have a message queue, and you have the consumers and producers consuming and publishing messages. And it really bothered me for the longest time that we didn't have a common way of describing these events. And we didn't have a common way of telling which service publishes what events and which service can receive what events and what's the format, all that kind of stuff. With REST and with HTTP, we had OpenAPI and the REST semantics for a long time. It was well established, whereas with event-driven, even though we had event-driven for a long time, we just didn't have the standards, and that kind of bothered me. But thankfully, I think we started having these standards, and that's what I want to talk to you about today, and that's what this talk is about. So first of all, let's do a little bit of introduction. Let's imagine you're building an event-driven kind of architecture, right? And this is a very simplified version, of course, but let's say you're building an event-driven order processing system where you have a front end that receives the requests, and then you have a number of services that kind of act on that request. So you might have a payment processor running on Cloud Run, which is a container service on Google Cloud. You might have a shipper function, which is on Cloud Function, which does the shipping. And then maybe you have a notification function or a container that sends a notification to the user, right? And in this event-driven architecture, each service, they receive an event and they act on it. They do something, and then at the end they send another event saying, okay, I'm finished what I did, what I need to do. So for example, the front end, once it's done, it will send this order received event with the information of the order, and then there's a message broker or event bus in the background looking at the messages and figuring out where should this message go, and it will figure out that, okay, this order received should go to this payment processor, then the payment processor will do its part, and then once it's finished, it will signal to the rest of the system that I am finished with this payment process message. And this goes on and on and on. And the key thing here is that these services, they don't know about each other, they don't care about each other, they are not communicating directly, they are communicating indirectly through events, through this message broker or event bus. And this allows us to have loosely coupled services where we can add them, remove them at will, and there's not tight coupling basically between services. Now, in this event-driven architectures, you need to decide a couple of things. First of all, you need to decide on the envelope of the events. How are these events going to be routed, and what information I'm going to use to route these events. And the second thing that you need to decide is that which service publishes what events or subscribes to what events, right? You need to decide on that, and you need to somehow communicate that so others can know and kind of know how to subscribe and how to publish. And the TLDR of my talk is that CloudEvents, it's an open source project that can give you an envelope, and I'll talk more about CloudEvents later. And then AsyncAPI, it can help you to document what is within your messages, so the format of your message, but it also helps you to document what service publishes what events and which messages you can subscribe to from which services, right? And also AsyncAPI gives you not just a way of documenting it, but also a way to use that information to visualize and also to have generators to generate code as well. So let's look into these in more detail. First of all, cloud events. Why we need cloud events? What problem it's trying to solve? Again, let's look at this at the high level. So usually when you look at event-driven systems, you have some event sources emitting some events. And then you have some event destinations where you want to route those events to, right? And usually there's something in the middle, or maybe many things in the middle, that will receive these events and it will route them, and maybe it will also process them a little bit, right? You might want to do a little bit of transformation to these events as well. Now, this gets more complicated because usually you have different event sources using different systems. So you might have an event source using Kafka as its transport protocol. Maybe you have an IoT system using another protocol, and maybe you have a cloud service on Google Cloud using Google Cloud PubSub, right? Now, the middleware has to do a lot more work. It's not simply taking some event type and then routing it to the destination. It needs to understand different protocols, Kafka protocol, MQTT, PubSub. And then it also needs to understand the different formats of these messages. The message might be in JSON. It can be more efficient protobuf. It can be Avro, right? And these messages can have different schemas. So reading events and routing ends up being quite difficult at every hop. And that's the problem that the cloud event is trying to solve. It's trying to give us a common way to describe these events so that we don't have to think about every single time, like what kind of event it is, how do I read it, how do I route it. It's an open source specification to define events, but also it's SDKs to read these events as well, to read and write these events. So it's not just specification, but it's also SDKs that you can use to read and write events. It defines a minimal set of what's called context attributes. So these attributes define how to route the event, and I'm going to show you an example in the next slide. And it also has a data field that basically applications use to put their own data. So the context attributes define how to route the event, and the data is what the applications can use to put their own custom data. So what does a cloud event look like? There are two formats of cloud events that you can use. The first one is called binary mode. And in binary mode, so this is a cloud event, for example, that I'm just sending using curl. First of all, the content type is application JSON. This determines the mode of the cloud event. So application JSON means this is a binary mode cloud event. Then there are some headers. And these headers start with CE dash. CE stands for cloud event. And these are the required, the minimal required cloud event headers that you need. So this is the spec version, then the type of the event, the source of the event, and the ID of the event. So you need these minimal set of headers to route the event. Then you have some optional headers that you can add, the time of the event and the subject of the event if you like. If your application has its own extensions, what's called extensions, you can add them as headers as well. So you can have extension header 1 and header 2 with their own values. So these are like custom headers that you can add for your events, for your own application. And finally, you have the data, the actual data that you want to send in the body of the message, right? So this is custom for every application. And these are the headers that you use to route the event. So that's the binary mode of cloud event. And this is good for receivers that might be unaware of cloud events. Because if you are a receiver who doesn't understand cloud event, you can simply ignore the headers and you will still get the data, right? But if you understand cloud events, then you can read the headers and use it to route the event. Now, the other mode of cloud event is called structured mode. And in structured mode, instead of using the headers of the events, we are using the body of the requests as the whole thing. So here, as we see, we only have one header. And this time, the header is cloud events plus JSON. So this tells us that this is a structured mode cloud event. And then we have the required fields of cloud event, the spec version, type, source, and ID. As you see, this is just in the body as JSON. It's not in the headers. Then we have the optional elements here. And then we have the extension attributes that your application might use. And finally, the data lives under the data field. So you're still sending your data, but it lives in this special field called data. The structured mode is good for, if you want to send your cloud event across different multiple routing hops, and you want to make sure that they are not dropped anywhere, then this is good because everything is in the body. So usually the routers, they don't touch the body, but they might look at the headers and maybe they will drop something because you have some special headers. So what else CloudEvents provide? So we have this format now that we can use. So it gives us the format, this common format, but this format can be in JSON, but it can also be protobuf, AURO, and XML. XML is in draft still. It has protocol bindings. So how does event travel over the wire? By default, it's HTTP, but it supports AMQP, Kafka, MQTT, and so on and so forth. It gives you SDKs to read and write these events in different languages. And also, different cloud providers provide cloud event libraries. Because, as I said, the cloud event SDK is for the envelope, but the actual data is in the data field. And you might need some libraries to read the data field as well. For example, Google Cloud has this repo to read Google Cloud events, Google Cloud storage events, for example. So what you would do is that you would read the envelope using the Cloud Event SDK, and then you would use this Google Cloud Event libraries to read the body of your Cloud event. All right, so it gives you pretty much everything you need to kind of send and receive messages, but you also need to keep in mind these limitations. I won't go through them in too much detail, but basically, there's batch mode, but not all protocols support it. Like, for example, JavaScript SDK supports HTTP and Kafka batch mode, but not MQTT batch mode. Not all event formats are supported in each SDK. For example, JavaScript SDK supports JSON, but it doesn't support AURO or protobuf. Not all protocol bindings are supported in each SDK. Again, JavaScript SDK supports HTTP and Kafka, but not AMQT, MQTT, or NATS. So the point of this slide is that just because there's all these different formats and protocols and all of that, it doesn't mean that all the combinations are valid given a language. So you need to look at the language that you want to use, and you want to make sure that the combination that you want is actually supported, okay? Because not all the combinations are supported today. And then finally, there's 3 specs coming up in CloudEvents: Discovery API, Subscriptions API, and Schema Registry. So these are all about how do you discover these events, how do you subscribe to them, and what their schema looks like, right? And I will talk about AsyncAPI shortly, and these are also in AsyncAPI. So I think CloudEvents and AsyncAPI, they're kind of stepping on their toes a little bit in that sense. But these are new specs from CloudEvents that are in progress, and at some point we'll also have more than just the format of the event, but also how to discover these events and also their schemas and all that kind of stuff. So it's something to keep in mind in the future versions of CloudEvents. All right, so as I mentioned, in event-driven architectures, you need to decide on the envelope. So I'm just telling you that CloudEvents is a good envelope that you can consider to use, so that you don't have to reinvent this envelope every single time. And it's open source, and it's something that's been around for a while now. But you still need to also decide how you're going to communicate, like which services publishes what events, and how can you subscribe to them. And that's when AsyncAPI comes into the picture, and that's what I want to talk about next. So AsyncAPI is another open source specification to define asynchronous APIs. So just like we had OpenAPI for REST APIs for a while, now finally we have AsyncAPI to define event-driven APIs. It's not only specification though, it's also a way to visualize that specification. So you have the specification, and then you can see how your architecture looks like, and also generators to generate code from that specification. So you can, for example, look at the spec, and you can generate a subscriber to that spec, or you can generate a producer for that spec in different languages. So the main concepts in AsyncAPI are these. At the top level, you have application, so that's your asynchronous application. Then you need to define a server. So how do people get to your application. This server can be HTTP, or it can be MQTT, or it can be Google Cloud PubSub. So it's basically like what is the protocol, the server and the protocol you're using. So you define a server. Server has a channel, one or more channels. Usually you have a non-trusted channel or a trusted channel. Then you define the protocol that you're speaking, HTTP or something else. Then finally, once you have this infrastructure in place, you define your producers and consumers. So who can send messages to these channels and who can receive messages, and what can they send. So the type of messages that they can send. So the format of that message as well, you can define. And finally, there's something called bindings. Bindings allows you to extend async API for your own protocols. For example, Google Cloud has Google Cloud PubSub bindings so that you can use async API to define your Google Cloud topologies. And I'm going to show you an example of this shortly. So these are the main concepts. And as soon as I show this to people, people start comparing async API to OpenAPI and what are the differences. I know this is probably hard to see, but in OpenAPI, you usually talk about paths, right? Because it's path-based protocol. And then you talk about operations on those paths. And the operations are typically HTTP operations, get, put, post, with requests and responses. So that's why in an async API you have your paths, you have your operations, and then you have your components where you define what these operations look like. Now in async API, it's similar kind of concept, but instead of paths, it's channel-based, right? Because in messaging, you send messages to a channel. So that's why you still have a server in both, but instead of paths, you have a channel. And then on channel, the operations that you have, it's only two, the publish operation or the subscribe operation. So you don't have all this put, get, and all that HTTP operations. It's either publish or subscribe. And then you don't have request and response. Instead, you have messages, right? So the message have headers and payload. So that's the difference. It's similar concepts, except it's OpenAPI applied to event-driven architectures. So you have the channel, operation, and the messages. And then you can define the format of the messages in the schemas down here. So how does an async API definition looks like? This is the simplest async API definition that's possible. So first, you define what version of the async API we are talking about. 2.6 is the latest one. 3.0 is coming soon. You define your application. So here we are saying that our application is hello world, and this is the version of the application. You need to define, well, if you don't define a server, it assumes that it's only one server, but you need to define at least one channel. So here we are defining under channels, one channel. The name of the channel is hello, and then the operation on the channel is publish. So this is a channel where you can publish messages to. And then you need to define what should the message look like. So in this case, the message has a payload, and the payload is a type string. So we are basically saying you can publish a message with a string payload, and that's it. So this is the simplest definition that you can have. If you look at actually another definition, I don't know if you will be able to see this, but I'll try to make this bigger. Let's make this as big as we can. Yeah, so here, for example, I'm defining the same hello world application. Here I'm defining a server. So this is an AMQP server. And then under my server, I'm going to define my channels. So I have one channel called hello, just like before, where you can publish a message. And here, we are not saying string right now. We are saying this message has a payload that's under components, messages, and hello message. So we're going to define that later. Then I have another channel, goodbye. And I can publish another message there, but this time this message is a goodbye message, right? So that's a different type of message. Then under components, we're going to actually define how these messages look like. So in components, we define the hello message, and the payload of that message is an object that has a string type, and then it also has a sent at type that we're going to define later. And then finally, the goodbye message also has an object type that has a send at type. And finally, under the schemas, we see that send at, it's a string, but the format is date time. So that's the That's the format. So you see here that we are defining exactly what server we have, what channel we have, what kind of messages you can send to, and also how does those messages look like as well. All right, let me see how I'm doing with time. 10 minutes, wow, time goes fast. And one thing that might be confusing in AsyncAPI is the publish subscribe operation. So remember, on the channel, you define publish and subscribe. And this can be confusing because depending on whose perspective you are looking at. So for example, if you, in AsyncAPI term, like a publish actually means a send in WebSocket. In WebSockets, you send a message. So in AsyncAPI, it means publish. And then subscribe means you receive a message from WebSocket, right? And then if you look at it from the server's perspective, publish means the server receives the message, and the subscribe means the server publishes the message. But then if you look at it from the user's perspective, publish means the user publishes messages to the server, and then subscribe means the user subscribe to receive messages from the server, right? So depending on from which perspective you're looking at or from which technology you're looking at, this can be confusing, but I think the user's perspective is the most useful. If you can think of it as the user doing the operation, then publish and subscribe from AsyncAPI kind of makes sense. So if you see a publish, it means user is publishing, and if you see a subscribe, it means users subscribing to receive messages. So once you have your AsyncAPI spec, there's Async Studio to visualize your architecture, and I'm going to show you an example of this. There's AsyncAPI CLI to work with your AsyncAPI specs, so to validate your spec and to generate code from it and stuff like that. And then there's also an AsyncAPI generator to take your spec and generate code from that for different languages. And actually, let me show you the Async Studio quickly. So this is online, and you can also install it locally if you want. But here you can paste your definition, like your AsyncAPI definition. So you see I have the AsyncAPI, the channel, and the messages that you can publish to the channel. So once you have that, then what you get is here, this visualization, where you see that, okay, I have these operations, and the operation is a publish operation, user signed up. Then the payload, let me make this a little bit bigger. Then the payload looks like this. So the data should have display name and email. And then the data should look like this. And the message is like this. So, and then here, by the way, this is a cloud event that I'm going to talk afterwards. You see exactly like what your operations are and what kind of messages you can pass into, and then how does that message should look like. And in some cases, you also see an example. I don't know if, yeah, for example, here you see that this is the headers that you should have, all that kind of stuff. So this is very useful to kind of document your event-driven architectures. All right. And then the generator, I don't think I have time to show you an example, but there is this project, basically, where you can, let me look at it on GitHub. So you can see, you can take your AsyncAPI spec and generate code from it. So there's a Node.js generator. There's a Java template that uses Java JMS or Java Spring, and so on and so forth. It's a small subset that you can generate. So again, not all combinations are supported, but for small subset of AsyncAPI, you can generate some code from it and then use that to test your architecture and see that it works with the test data that the generator gives you. So it's something to look into, although I found generators a little bit lacking. They don't work. Some of them, I couldn't get them working, and some of them, they're outdated. So you have to, they're not going to work for all your specs, but it's a good starting point if you don't know how to send messages and receive messages. Okay. So we have the envelope with CloudEvents, then we have AsyncAPI to document our services. So I think we are in a good shape to document our event-driven architectures. And then once I figured this out, I wanted to look into some cases where I have my services publishing cloud events or receiving cloud events. Is that possible to define in AsyncAPI? And I also wanted to see, I have this Google Cloud PubSub topics. Can I use AsyncAPI to kind of document those as well? And the answer to both is yes. You can use AsyncAPI and cloud events together. And let me show you an example of this. For example, in cloud events, if you remember, I told you that we have this structured mode where the whole message is in the body, right? So the cloud event spec and also your data is in the body. So how can you document this using AsyncAPI? Well, the cool thing about AsyncAPI is that you can refer to other specs from AsyncAPI. So here I'm defining my AsyncAPI, and I'm saying that, okay, I have a channel. This is a user signed up channel, and you can publish a message to it. And then this message have these headers. And these headers, the payload has this user signed up payload. And then if you look at the payload, I'm saying that one of the payloads is all of this. And all of this is a cloud event spec, right? And if you go to this link, you will see that this is the cloud event spec in JSON. So by just referring to my cloud event spec, now I can document this in AsyncAPI, and then you can look at it in AsyncAPI Studio, and you can see the cloud event and the format of that cloud event, right? So I think this is pretty cool and shows how extensible AsyncAPI is. Now, the other format of cloud event is the binary mode, where you have the headers instead of the body. So how can you document something like this? Again, you can do this, but you need to use what's called message traits. Message traits is something you can specify in AsyncAPI, where you can say, all my messages will have these headers, right? So in this case, the headers that we want to have is the cloud event headers. So what I do is first I go and define my traits in a separate file. So this is my traits, the file that I defined. And I'm saying that, okay, these are cloud events headers. And then these headers are the required ones, spec version, ID, and source and type. And then I think I also define anything that's not in the required field is optional. So I define those as well with their formats and types and all that kind of stuff. And then once I have this, I can go to my binary definition. And then I'm defining the same channel, the same message, but then under my message definition, I am defining a trait, and I'm pointing to my traits that I defined. So by doing this, I'm basically telling AsyncAPI that, okay, all of my messages, they should have these headers, and within that traits, I tell it which ones are the required ones, and so on and so forth. So that works pretty well as well, and I was very happy to see that AsyncAPI is so extensible to support this. And finally, the last thing I want to mention is, so this is all open source and all good, but then I'm also running some services on Google Cloud. So can I use Google Cloud PubSub and AsyncAPI together? And I thought I couldn't do this, to be honest, because it's open source. Google Cloud is like Google's stuff, so maybe they don't work together. But I was pleasantly surprised to see that this also works, and this works through what's called bindings, and I'll show you again here. AsyncAPI can be extended with what's called bindings, and in the bindings, custom protocols like Google Cloud PubSub can define what it means to basically have a Google Cloud PubSub topic, right? So here, I'm defining my server, and then under my server, under my channel, I define one channel, and then here I'm specifying a binding. And then the binding is Google Cloud PubSub, and then in here, we point to Google Cloud PubSub topic. So this is a topic in Google Cloud. And then the publish and subscribe is basically pretty much like before. So these bindings, anyone can add them. So an engineer at Google, they worked on these Google Cloud PubSub bindings. And because of this, now you can specify your PubSub topics and tell people how to call it, what the schema looks like. And yeah, and you specify the settings for the message as well. You see like the persistent regions and stuff like this is specific to Google Cloud, but you can specify them in AsyncAPI, and people can use that information when they're calling your service. All right. OK, I think I'm out of time, and that's all I wanted to say. So basically, I'm pleasantly surprised with CloudEvents, and also especially with AsyncAPI to document our services. It's very extensible. So the whole point of my talk is that please take a look, because they're very useful to at least document your services, but they're also providing more than that with generators and schema and all that kind of stuff to give you more than just documenting your services. So if you want the slides, this is my slide link. I have 2 GitHub repos, CloudEvents Basics and AsyncAPI Basics, that have a lot of samples on all of this stuff. So feel free to check them out. And enjoy the rest of the conference. Thanks very much.